Hey folks, welcome to this tutorial video. This video is going to cover some advanced debugging techniques. The context of this video is as follows. I have a student who is currently doing project 11. They are having trouble figuring out why their release pool is not working as expected. The purpose of the release pool is to allow objects that are created on the heap to not be destroyed on the audio thread. So that's one of the things we cover in this course. So I'm going to show how to figure out where things are being destructed, where they are being created, what things in the code are causing the reference count of these objects to increment and decrement. So that's what we're going to cover in this video, and I'm going to do my best to not speak too fast and not eat my words. Okay, so I've got this set up to use audio plugin host, and I have a breakpoint where the first filter coefficient object gets created in this plugin. So we're going to run this, and we're going to start taking a look at what's going on here. Okay, so PTR is a reference counted object pointer that holds a DSPIIR coefficients object. Right now it is null because we haven't created one, so we're going to call this makePeakFilter function. MakePeakFilter function is a static function in the IIR coefficients class. This is part of the Juice framework. Now, the coefficients object inherits from processor state, and processor state is a reference counted object. Oh, sorry, that's just a forward declaration. We'll check that in just a minute. It's a reference counted object. Just trust me on that. Okay. We are going to jump to where it actually creates the coefficient object. So I'm going to just click the step over button. Now I'm going to highly encourage you to learn your keyboard shortcuts. The continue button, step over, step into, step out. Every debugger has these default assigned. You have the buttons themselves down here in the debugger. You got your variable inspector here. But every debugger, Xcode, Visual Studio, C Lions, all that stuff, they all have this same stuff. So don't be swayed by the fact that you're seeing this in Xcode. Visual Studio is going to show you the same thing. It's going to show you the call stack, which shows the functions that are currently being called. It's got the variable inspector, and then it has the buttons to continue execution, to step over the current line of code, to step into the current line of code, and to step out of the current scope. All right, so let's just do that. We're going to step in and step out and pay attention to the lifetime of this coefficients object. All right, so we're just going to step over all of this stuff, stepping over each line. Now I'm on this line where it's going to create a coefficients object. Okay, so I'm going to click step in until it actually goes into this constructor. You can see what's going to get executed based on this green line underneath the code. All right, so let's do that. Step in. And now we are in this coefficients class constructor. Now it's on this curly brace, which means it's not going to actually start doing this stuff yet. What it has to do first is initialize the base class and then initialize any member variables that are in the class. As you can see here on the right, it's a ton of static stuff, but there is one array member variable. All right, so we'll get there. Okay, so we're going to step in and see what gets constructed. Okay, so we're still on this constructor. It's the declaration of it. And now it's going to jump to this processor state constructor, because you can see if I jump back in the call stack, you can see that this object has a processor state member variable. This is the base class. And same for this processor state, because processor state inherits from reference counted object, it has a reference counted object member. That's always the first member in a class that inherits from another class. Now you can also see that this reference count is a garbage value, negative 65,300. Okay, so we're going to jump in here. It's going to initialize this reference counted object, which is also being default constructed. What that means is that it's going to default construct the member variables. In this case, this class just has one member variable, this atomic value right here. Okay, so it's going to default construct that next. All right, here it's going to construct this ref count. Again, remember, we have our garbage value right here. Okay, so let's step into that. Here's where it's actually going to construct it. The initial value is 0, and that's going to get assigned to the actual value member variable. And there it goes. Okay, the atomic has been initialized with a ref count of 0. Okay, So now we can, I'm going to click step in, and what that's going to do is execute this closing curly brace, which means it's going to leave the scope of this atomic constructor. All right, there it goes. Now it's going to leave the scope of this default constructor for reference counted object, and we can see that the reference count is 0. Okay, pay attention to this number right here, 27DDA0. All right, so we're going to leave the reference counted object constructor, and now we are currently going to finish initializing this processor state. So we're going to leave this scope, and now we're back at our processor state. We just finished initializing this guy, the base class member variable, and now we're going to continue initializing our coefficients object. All right, and just as a refresher, we can see that our processor state lives at 27DDA0. Again, remember that address. Okay, and we can see that our reference count is currently 0. All right, I'm going to step in, and it's going to jump to this constructor. It's done initializing the base class, but it has not initialized the array member variable yet. So it should do that next. All right, still going. Okay, here, now it's going to start initializing this object right here. Okay, so check it out. We just finished initializing this IIR coefficients base class processor state, and now we're going to initialize the member variable coefficients next, which is a juice array. That's what's going on right here. All right, so if we step in, we can see it's going to do that. It's going to default construct this array. Now, array internally uses array base, and array base inherits from, or array base internally has a heap block. Let me see, I think this is way down at the bottom. Yes, here's the array base class. So it's going to initialize that next because that's the only member variable. And then this thing, array base, doesn't inherit from anybody. Well, it inherits from whatever we provide here, which is a dummy critical section. So it's going to initialize the member variable, which is a heap block. Okay, so we can kind of see where all this stuff is going on. All right, there it's initializing the heap block because dummy critical section is nothing. All right, so now we're going to leave this array base constructor. It's going to initialize these two other member variables. You can see that going on here. We've got our elements, the heap block, and then our num allocated and our num used. Those get set to their default value of 0 and 0. Okay, we're going to leave this guy. And now we're back to our array constructor, which is being called from the coefficients constructor. We're not on this line of code yet. We're still initializing the member variables. Once this is done, then we will see this JAssert get executed. All right, so we're going to step in. That's going to start to leave this right here. All right, now we are on this JAssert. Now we don't care about any of this stuff that's running in this constructor, the clear, the computation of this thing, and then adding that stuff. Okay, so we can just step over all of that. Okay. Now it's going to leave this constructor, which is going to take us back to where our coefficient object pointer, which is what gets returned from this function, is actually being created. Okay. So once we step into that, that's going to create the reference counted object. Okay, and we can see that our reference counted object pointer type is DSPIIR coefficients. Okay, now if you remember, we had our reference counted object, which was 27DDA0. Okay, that's important. Now our reference count is 0 because we haven't been used in a pointer yet. So that's what's going to happen next. Okay, it's going to use this reference counted object, and it's going to increment that pointer. Okay, so let's do that. So our this object, this reference counted object pointer, now has a referenced object that it owns, and that referenced object is that 27DDA0 instance of the IIR coefficients object. Okay, reference count is still 0. So if I step in over this, we can see where it actually does that reference count. This is going to increment the atomic. Okay, so step in over that. It's going to invoke this increment operator. All right, it's done with that. And we can see that our reference count is now 1, again for our 27DDA0 instance. Okay, all right, step in over that. This is going to leave this constructor. Again, we still have this value of 1 for our reference count. That's the number to take to count. That's the thing to remember. All right, Let's step in again. This is going to leave this function, and that's going to start to invoke this assignment. All right, we can see that our PTR is currently null. That's the thing on this side of the equal sign. But once we press step in, that's going to invoke that copy. And it's going to invoke std swap. So you can see this object right here is the one that was on the left side of the equal sign. And this one right here, the other instance, is the one that's on the right side. It's our 27ddA0 instance that we've been keeping track of, okay? So let's step in, and it's going to do that swap. And now we can see that the other instance, which is the one that was on the right side of the equal sign, is now null. And the one that was on the left side, the PTR, if we look at this PTR, we can see that it now contains 27ddA0. Okay, and the reference count is still 1. All right, so let's step in and step in again. Now it's going to decrement the one that was null. This is because the one on the right side of this equal sign has gone out of scope. So that's why it's currently decrementing that. All right, so we'll step in. Decrement if not null referenced object. You can see that it currently is null right here. So we'll step into that. It's going to check if it's not null. Step in. Nothing happened because it was null, so it didn't decrement the reference count. Okay, so we're going to leave this function. We're going to leave this destructor. And now we're going to tackle this break statement. We can see that our PTR is still 27ddA0, and it still has a reference count of 1. Okay, exit that. It's going to return this pointer somewhere. Let's see where it gets returned to. All right, it returned from this call function. Okay, so we don't have our return value yet because we haven't executed the return statement. We've only executed the call statement. All right, let's do that. Step in, and now we have this coefficients object. We can see it's our 27ddA0, and it has a reference counted value of 1. Okay, so this is going to get copied over to this one right here. And it actually already happened. Now it's going to call this update coefficients function. And if this function passes by copy, the reference count will go up. If it's passed by const reference, the reference count will stay at 1. Let's step in and see what it does. Okay, the reference count is still 1, so we know that it was passed by const reference. Okay, cool. So it's going to call this update filter state function. And this function may take a copy or it may pass by reference. Let's see what it does. Okay, so it passed one of the instances by copy. Let's see which one. It is our 27ddA0 is the other instance, and the one that's being copied, or the one that's being copied into, is a different object altogether. We'll go into detail about that in just a minute. All right, so what it's going to do is it's going to increment the reference count after it makes an internal copy of the pointer. All right, so our referenced object right here. We can see that this is also a 27ddA0. It's the same one as this one that was passed in. All right, so let's go to this increment if not null referenced object. We can see that O is our 27ddA0. Let's take a look at that reference count. And if O is not a null pointer, we're going to increase that reference count. Again, we just want to figure out where do these reference counts get increased. All right, so we're going to jump in there. We can see that our atomic is having its increment operator called. And there it goes. Now we have a reference count of 2. Okay, we're going to leave this function. We're going to leave this function. We're going to leave this function. One more time. And now we're back to this update filter state function. So this coefficients object right here has been copied to whatever is going to be passed to this this update filter state function. So once I press step in, it's going to take us to this update filter state function. And here we go. So we just created, this is the one that was copied right here, this new state one. All right, now we're going to add it to the release pool. And if this add function passes by copy, then it's going to bump up this reference count again, which we can see here is 2. Again, it's our 27ddA0 instance of the reference counted object pointer. So here we go. Let's step in on that and see what it does. Does it make a copy? It does. Okay. Our other instance is 27ddA0 with a reference count of 2. So let's do that. Now it's going to make this copy. The referenced object is 27DDA0. All right, awesome. It's going to do that increment. We already know this is going to change from 2 to 3. So let's step in and step on again to leave this function. And now it's going to jump into the add because this new state has been copied into a new variable, and we're going to go into the scope of this add function. Okay, step into there. Here's the new one that was created. We can see we have our reference count of 3, and it's still our 27DDA0. Okay, let's jump over this, check if we're on the message thread or not. And now we're going to call this add if not already there, which may pass by copy or it may not. Let's step in and see what it does. It's creating a copy. Okay, cool. We've already seen that happen a bunch of times. Now our reference count is 4. Again, it's still 27DDA0. Okay, step into this. It's going to leave this function. And now the value that is going to be passed to this function is a copy of this one. Okay, so, and we can verify that by just looking at this address. Is this showing us the address? It's not. But this, we can actually print that out here if we do, what is it? PTR? Is that what it is? Address of PTR. That's what we want. All right, here it is. Okay, the address of this function variable right here, PTR, is this thing right here. Okay. All right, so we are going to jump into this add if not already there. And we can see if I print this PTR instance for this function, now that I'm in this scope, I'll do the same thing. We can see that it has a different memory address. We've got CB08 versus CAB0. Okay, that's how we know that this instance that's inside this function is different from the instance that was in this function. Okay, we still have our reference count of 4. The next scope that gets used is this lambda right here. We can see that I'm passing this by copy. So if I step in, it's going to increment this reference count again. There it goes. It's incrementing it. You can see it's our 27DDA0. Here's our, we can see that we have our CAB0 instance, which is this one here. That's the one that's being passed by copy from here to inside this curly brace. All right. And we can see the address of the one that's being used inside the curly brace right here. We can see it's CA48, which is different than this CAB0. All right, if I step in, it's going to increment. Okay, CA48 is different from CAB0, but it has the same internal 27DDA0 instance of our coefficient object. Okay, we already know what happens when we increment the reference count. This is going to go from 4 to 5. Just like that. All right, we're going to step out of this function, or I'm going to press step in, and that's going to leave this scope. All right. Now we are about to be done with the scope of these curly braces right here of this lambda, which means this is going to change from 5 to 4. All right, there's our anonymous class, which is currently using the PTR. If I inspect this ref count value, still 5. I'm going to press step in again, and that's going to make the PTR go out of scope. One more time. There it goes. It's going out of scope. Again, our CA48 from earlier in the video. Step in, step over, reference count of 4. Okay. There we go. We just finished using that. Now it's going to initialize the found object. Okay, great. So like we said, reference count of 4. Okay. Now if it's in the deletion pool, it's not going to get added. If it's not in the deletion pool, it will get added. And adding it to the deletion pool will increase the reference count one more time. And there it goes. Okay, reference count went up to 5. All right. So now we're going to leave this scope of this copy. All right, so if I step in, this is going to decrement. This is decrementing the CAB0, which, as we showed, was the one that was inside of this add if not already there function. All right, so we'll do that. We'll step over this. step in to leave the function. We can see our reference count is back to 4. And now we're going to leave these curly braces. All right, now we're on these curly braces, and the one that's going to go out of scope now, this instance, is going to be this one. If I print that out. Yes. CB08. That is the address of this guy right here. This is going to go out of scope. Whoops. All right, and that's this. The lifetime of the copy of new state is going to end. All right, so if we step over that, that's going to decrement our CB08. Step over that, step in to leave this function. Okay, now our reference count is 3. And we can see that new state right here. If we print that address out, it's a different object. P address of new state. Oops, let me spell that right. You can see that that's CB58. Totally different object from the one that was being used inside of this, but the internal referenced object has the same address, okay? So let's step in to leave that. Now it's going to perform this copy. It's dereferencing them. Now it's invoking the copy operator of old state, or copy constructor, which is a default constructor. Sorry, not copy constructor, a default assignment operator. And that's just going to make a copy of all of the member variables, in this case, just that array. All right, we can see it do that. It's going to copy the referenced object as well. All right. And here it goes, it's invoking that copy operator of the array class member variable. All right, let's leave this because we don't care about this. Step 8. F8 to step out in Xcode. That's how I have my keyboard shortcuts set up. All right, I'm going to step in to see what else it does. All right, now it's going to leave the scope of this update filter function, which means that new state is going to get decremented again. Okay, step out. And we're going to leave the scope of this copy. Like that. Here we are, our 27DDA0. Okay, step over that. And our reference count is now 2. Okay, we're going to leave the scope of this update coefficients function. And that takes us back to our coefficients object. Okay, this is this local variable. It has a reference count of 2. When we get to this curly brace, this is going to disappear, which means we're going to have a reference count of 1 of our coefficients of this guy internally. Okay. All right. Coefficients is gone. Okay, we didn't get to see it get destructed. If I step in, will I get to see it destructed? There it goes. All right. 27DDA0. This is going to go out of scope, and it's going to decrement this reference count. All right. We already saw it do this, so we can just step over that. There we go. Reference count of 1. All right. Let's leave this guy. And now we're going to leave this curly brace and jump to this curly brace. Okay. So how can we verify that the instance that we've been working with has a reference count of 1 and is still alive? We can inspect where it got added in the release pool. It's inside this filter link class. It has all these member variables. We can go down to our release pool right here. We can inspect the actual deletion pool, and it will be the first element in there. This one right here. And we can see it's our 27DDA0 instance that we've been tracking this whole time. And if we look at the reference count, it has a reference count of 1. This is the only place it's being used. Okay, so once I leave this scope, it's going to take us back to some other code which is not relevant to this project. But there you go, okay? So we did some advanced debugging. We looked at the lifetime of these reference counted objects and the things that keep them alive and keep them from going out of scope, the things that bump the reference count up, the things that drop the reference count down. We looked at how to print out the values of, the addresses of the variables and whatnot in the debugger. So these are some advanced techniques. And I hope you find this helpful for just learning how to use the debugger in Xcode as well as in Visual Studio and to know what you're looking at. The whole point of this course was to just teach, you're staring at code. What am I looking at? I have no idea what any of this stuff means, and hopefully a little bit of insight was gained on that front. All right, thank you so much for watching. Thanks to all of my Cordy app customers as well as all of my students in Programming for Musicians. I am forever grateful that you guys are trusting me with your time and your time and your dollars as well. Like the fact that you guys are investing in yourself by supporting this stuff is so awesome for me. So thank you so much. I hope you found this video valuable, and I hope that you're able to get further along in your projects with the knowledge you gained from this video. All right, I will see you in the next video. Have a good one.